Hello, and welcome to my presentation on our second project for data mining. My name is Nash Morrison, and this project, completed as part of Team 13 using a collaborative Google Notebook, focuses on decision tree and neural network classifications. Let us dive into the details. Our program was written in Python with 20 plus hours of research and development, with an additional 5 plus hours on the PowerPoint, with the ultimate creation of a YouTube video, which was all done by me. The dataset I worked with looked at predicting student outcomes. Specifically, I am looking at accurate predictions on whether they drop out, stay enrolled, or graduate. Consisting of 4,424 rows by 37 columns, the dataset covers attributes like admission grade, enrollment age, and employment rates, which were selectively chosen to determine our predictions based on personal interests. The target variable had 3 classes: dropout, enrolled, and graduate. Data types included both continuous and categorical features, with processing done by pandas and NumPy for analysis and model development. For our hyperparameters, white indicates test 1, while the black indicates test 2. And just to briefly go over, our Gini index is a metric used to measure the diversity of a dataset at a given node, indicating how likely a randomly chosen data point would misclassify if labeled based on the class distribution within that node. So a lower index is good. Entropy is the measure of disorder or uncertainty of a given dataset, looking to reduce that uncertainty, so in contrast, higher entropy is good. For a decision tree, max depth is the maximum depth of the tree. Minimum sample splits is the minimum number of samples required to split an internal node. Minimum sample leafs are the minimum number of samples required to be at a leaf node, and our random state controls the randomness of the estimator. For 2 optimizers, we went with Atom, which is best suited for larger data sets with fast convergence, and SGD, or Stochastic Gradient Descent, which is best used when aiming for better generalization or when computation and memory constraints are critical. Initial learning rate is the initial setup size when updating the weights, and momentum is used for gradient descent updates. Ultimately, looking to see if increasing the number of layers increases our accuracy. Moving to our first model, our Gini index scores ranged from 0.394, which correctly classified 6.4% of the samples as enrolled, to a perfect 0, which captured 0.4% as enrolled. Entropy, however, the results were more mixed, so we had scores around 1.58, reflecting the challenges of classifying smaller classes like dropout and graduate. But overall, decision trees provided clear and interpretable results, but struggle with underrepresented classes, especially graduate. For our neural networks, the Atom optimizer achieved 54.12% accuracy, slightly outperforming decision trees at 53.99%, along with other hyperparameter tweaks of both models. Confusion matrices highlighted significant misclassifications, especially between dropout and enrolled, and unfortunately there were no correct predictions for the graduate class, reflecting a bias towards majority classes. Rigorous testing and fine-tuning were conducted to improve these results. However, as we can see, challenges with minority class predictions persisted through multiple iterations of testing. And just as a note, the user-made accuracy functions for the confusion matrices match with the accuracy score function call for optimizers, proving our calculations to be exact. In conclusion, while both decision trees and neural networks provided valuable insights, each has its own strengths and weaknesses. Decision trees excel in interpretability, but struggle with imbalances, while neural networks offer adaptability, but need more optimization for minority classes. So to address these issues, future work could include the possibility of balancing the data set more, particularly for the graduate class, adding more predictive attributes to enrich the data set, or possibly fine-tuning hyperparameters to enhance overall performance and class performance. So I thank you for your time, and I am happy to answer any questions in the comments below. Thank you very much.